My name is Jay, and today we will be learning about prime factorization. What is a prime number? A prime number is a number that can only be factored by itself and 1. A prime number must be greater than 1 because 1 isn't prime or composite. All whole numbers can be expressed as a product of prime numbers. What is a composite number? A composite number is a number that has more factors than itself and 1. A composite number can't be 1 because 1 isn't prime or composite. Every composite number can be broken down into prime factors, as known as prime factorization. Now, what is prime factorization? Prime factorization is when a number can be broken down into its prime factors, which are prime numbers that multiply together to equal the original number. This process reveals the building blocks of the number and is unique for every integer greater than 1 according to the fundamental theorem of arithmetic. Prime factorization is used in various areas of mathematics, including simplifying fractions, finding the greatest common divisor, also known as GCD, and determining divisibility. It also plays a crucial role in fields like cryptography and computer science. Examples of prime factorization. Suppose we want to find the prime factorization of 48. First, we would want to start with the number 48. Second, we would want to divide by the smallest prime number possible, which is 2. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. And 6 divided by 2 is 3. And since 3 is prime, 3 will also count as a factor. We can also now say that the final prime factorization is 2 to the power of 4 times 3, or 2 times 2 times 2 times 2 times 3. Note, if you want to simplify the same prime number into one character, then you would want to use exponents. Over here we can see that there are 4 2's and 1 3, which would make for a very chunky prime factorization. Instead, we can simplify those 4 2's into one character, which would be 2 to the power of 4. Also, there is also a tree chart to describe the prime factorization method of 48. We can see right now that 48 divided by 2 is 24, which is divided by 2 is 12, divided by 2 6, divided by 2 3. And we can also see that all the prime factors are separated from the non-prime factors. Now we will move on to the real life situation. Let's say you have $12 million and you want to deposit them into banks. You want each bank to have the same amount of money. How can you figure out all the ways to divide the money evenly into the banks? Now, I would advise you to pause here and think about the problem. When you're ready, unpause and continue on the next slide. The solution is, we'll use prime factorization to help us, obviously. Step 1. We would want to start by the amount of money we have, which is $12 million. The step number 2 would be to break 12 down into smaller parts using simple numbers. First, we can divide 12 by 2, because 2 is a prime factor of 12. 12 divided by 2 is 6. Now we have $6 million left, so let's divide 6 by 2 again. 6 divided by 2 is 3. Now we have $3 million left, and 3 is a prime number, so we can't divide it anymore. So 12 would be equal 2 times 2 times 3, or 2 to the power of 2 times 3. Last step means we can deposit in banks with these different amounts of money. We can deposit in one bank with $12 million, or two banks with $6 million each, or three banks with $4 million each, or four banks with $3 million each. And here we go. That's the end. Thank you for watching, and don't forget to like and subscribe.